Hello everyone, Dr. Chen here. So we're going to start to learn the Newton's laws of motion. Isaac Newton was born in 1642. If he is still alive, he would be close to 400 years old, very close to 400 years old right now. And he was born the same year that Galileo died. And we all know that Newton's law of motion was built largely based upon Galileo's discovery. He is of course considered one of the greatest, not only physicists, but one of the greatest scientists in history. He not only makes scientific contribution to what we're going to learn about motion and gravity, he also found out a lot of discovery in optics. So he's the one who invented the prism. And he discovered that if you shine a sunlight, there is no color in sunlight to us, and it was split into a lot of colors, and a lot of other contributions in optics. And he's basically father of geometric optics. Not only that, he's the one who invented calculus. So he's also considered one of the best mathematicians in history. He has other contributions in algebra, religions, and something like that. And Newton's theory about law of motion is based on the concept of force. So what is a force that we're going to learn in this class? Now, of course, it's going to be different than the definition of force in the Star Wars movie as shown in the picture. What is a force? This is an example of force that a tennis racket pad the tennis ball, and then you can clearly see that the tennis ball changed its shape during the short time of contact. So this force, right? And we have a lot of different forces. In our everyday life, we have spring force, we have tension, we have kick force, which we would also call it the normal force actually should be. We have gravity. The two masses attract each other. And then if you have a charge, we have electric force, we have magnetic force. Those are the forces. And this summarizes what is a force. So a force is a push or pull, try to change the motion of the object, right? And it has to act on an object. It has some agent to apply the force. Force is a vector. Now, so this is a property of force. A force requires an agent apply the force to an object, and the force has a direction. Depends on which direction you apply the force. And the effect is push or pull for the force. Now we have contact force, that two objects has force against each other only if they have contact. And then we have non-contact force, for example gravity. And then we know the Earth is applying a force on the Moon, but the Moon and the Earth is not in contact. Another example of non-contacting force would be electromagnetic force, right? So we catalog the forces we're going to learn in this class. Gravity, the direction for us on the surface of Earth would be always pointing toward the center of Earth. And then we have spring force. The direction of spring force. We have normal force. Now, normal force means the direction of this normal force is always perpendicular to the surface. Then we have tension. What's the direction of tension? Tension is always a force that pointing along the string, the rope. And if you have a rope that is in tension, basically straight up, then the tension force is the same all along the rope. Then we have friction. Friction is a force perpendicular to the surface of contact, which we're going to discuss in detail later. Now, right now we know there are 4 different kinds of fundamental force. We have strong nuclear force, we have electromagnetic force, which we're going to discuss intensively in physics 112, and then we have weak force, we have gravitational force. So for us, most of the force we experience goes back to electromagnetic force, like friction, normal force, tension, spring force. Those are actually all due to the electromagnetic force of the small particles in the material. Okay, now we need to introduce a concept of net force. So what is a net force? Net force on the object is a vector sum of all forces acting on the object. So let's see, we have an object. There are 2 forces acting on it. We have a 4 Newton force pointing to the left and a 10 Newton force pointing to the right. So if we add those 2 vectors together, what do we get? If we add them as vectors, right, which we have already learned, we'll find out 4 Newton to the left add up to 10 Newton to the right would give us 6 Newton to the right. Then we would call this is the net force due to those 2 forces acting on this object. So net force. That's individual forces. Now, in this example, we have a 3 Newton force acting pointing up, 4 Newton force pointing to the right. Then we need to do the vector sum. So for the net force is a sum of 4 Newton force pointing to the right, 4 Newton force, and 3 Newton force pointing up, 3 Newton force pointing up, 3 Newton. So we can use Pythagorean theorem to calculate the magnitude of this force. 3 square plus 4 square will be 9 plus 16 give us 25, square root 25, which exactly give us 5. Okay? So the net force is 5 Newton, but is pointing in this direction. This is a net force of 3 Newton force and 4 Newton force add up together. So that's a concept of net force. And we need, this is exactly why we need to be very familiar with vector algebra to learn this chapter.